I'm Jessie Pius from Rohini College of Engineering and Technology. Today I'd like to explain about the energy transfer of a wave. The mechanical energy is transformed through the vibration of the string. As a wave propagates in a medium, it transports the energy. It means a vibrating string has more energy than a string that is not vibrating. Consider the string under uniform tension T. If m is the mass per unit length and if a small length of the string of length dx is considered, then the mass is m into dx. So as the string is vibrating, the kinetic energy of the small element is dk is half m into velocity square. So it's equal to half m into dx dy by dt the whole square. Dy is the vertical displacement, x the direction of propagation of the wave. When the string is displaced from the equilibrium, a segment associated with interval dx has length dl. So dl is equal to square root of dx square plus dy square. So that can be written as dx into square root of 1 plus dy by dx the whole square. That's equal to dx into 1 plus half into dy by dx the whole square. So thus under the tension, a small segment of the string has expanded by the amount delta L is equal to dl minus dx. That's equal to half into dy by dx the whole square into dz. So the work is done for this expansion and it is restored as potential energy. This string is vibrating with displacement y of x comma t is equal to a cos omega t minus kx. Therefore the potential energy du is equal to t into dl. So that's equal to half into t into dy by dx the whole square into dx. So an element of string under the action of a wave is shown here. Differentiating 3 with respect to x, dy by dx is equal to ka sine of omega t minus kx. So squaring it, you'll be getting equation 5. Substituting 5 in 4, du is equal to half into t k square a square sine square omega t minus kx into dx. That's equal to half m omega square a square sine square omega t minus kx into dx. So differentiating 3 with respect to time, dy by dt is minus omega a sine omega t minus kx. So dy by dt the whole square is omega square a square sine square omega t minus kx. Substituting 7 in 1, you will be getting the next equation. Then comparing the 6 and 8, du is equal to dk. So total energy is summation of du plus dk. So that's equal to 2 dk. So d is equal to m omega square a square sine square omega t minus kx into dx. The quantity dE by dx is called the linear energy density. At any point, for example, x is equal to 0, the value of sine square omega t is equal to half. So dE by dx is half m a omega the whole square. This relation is called average density. As the average power transmitted by the wave is P is equal to dE by dt, equation 11 becomes half m a omega the whole square into dx. So P is equal to half m a omega square dx by dt. So P is equal to half m a omega the whole square into v, where v is dx by dt is the wave velocity. So equation 13 states that power is directly proportional to the speed or velocity at which the energy moves along the wave. Thank you.